In this session, we have to understand this concept that is called uh, simulation of electrical circuits with dependent sources. So we know there are four different types of dependent sources. Okay, dependent sources. First one is called voltage controlled voltage source, voltage controlled current source, current controlled voltage source, current controlled current source. So like this, four different types of dependent sources present in this electrical circuits. So to get these dependent sources in Matlab Simulink, right here voltage controlled voltage source, voltage control, voltage control. This is called voltage controlled current source, voltage controlled current source. It will take some time. This is called voltage controlled current source. Okay, so the voltage controlled current source looks like a circle and also plus minus. The plus minus is called depending parameters. It is depending on another parameters, another resistor, another branch, plus minus. This is called source. Current source is depending on voltage. That's why it is called as a voltage controlled current source. Circle is represented as a current source. This is called voltage controlled current source. The next voltage controlled voltage source. Right here, voltage controlled voltage source. Voltage controlled voltage source. This is called voltage controlled voltage source. Voltage controlled voltage source. Here the circle is represent source, that is called voltage source, and is depending on voltage. That's why plus minus indication is called voltage. Depending parameters, and this circle is called source. Voltage controlled voltage source. This is called current voltage controlled current source. And the next voltage controlled voltage source is over. Then coming to the current controlled current source. CURT, current controlled, here current controlled current source. This terminal, this element is called current controlled current source. Current controlled current source. The current controlled current source, circle is represent source and is depending upon current direction. Current flowing to the resistor or any other branch current. Okay, this is called current controlled current source. Next, current controlled voltage source. Right here, current controlled voltage source. Current controlled voltage source. Current controlled voltage source is depending on current, but the circle is represent voltage source. It is depending on current. Okay, like this, four different types of dependent sources present in this electrical network. So one by one, we can implement these sources. Okay, first how to connect the voltage control current source. Okay, then after that voltage control voltage source we will discuss one by one. Okay, first delete this one by one, and here first I am using voltage controlled current source. Voltage controlled current source. How to connect voltage controlled current source into the network? Take one simple network. Okay, so it's having three terminals. First take one DC voltage source. DC voltage source. It will take some time to get. This is called DC voltage source. This if it is black, is called black color. It is for Simulink. It can be used for Simulink. So light blue color. DC voltage source, DC current source, or DC voltage source. Take this type of check. This type of circuit is used to for simscape. Okay, complete black is nothing but that is useful for Simulink circuits. Okay, for simscape circuits, some it is not in black color, it is some light blue color. Okay, take one resistor. Resistor. This is called resistor. Okay, and take one more resistor. Right click on copy, paste like this, and one more resistor. Press Control R. It will be rotate like this. So voltage controlled current source. For example, this here, this is dependent source present here. The direction of the current is called upward direction. Let us assume current direction is called upward direction, and then connect these all parameters like this fashion. Okay. Here the circle is called source. Okay. And in this way, connection is over. Voltage controlled current. So circle is connected is over. And is depending upon the plus minus is called voltage controlled parameters. And then by using this connect, for example, 4Vx. Let us assume 4Vx. 4Vx means this is called voltage Vx is present is depends on this resistor. That's why connect like just like current connect just like what is this called voltmeter. Okay, like voltmeter connect exactly like so the voltage across the resistor. No, that's why connect exactly parallel to this resistor. Connect this terminal. So exactly parallel. So if it is this voltage control is depending upon the source, depending source is depends upon this resistor R2. That's why connect this voltage parameter depending parameter exactly parallel. If it is R1, if it is resistor R, connect exactly parallel to this resistor. Okay. And for example, this is called 4Bx. Na? Okay, open and right here transconductance constant 4 like this. Apply 4 transconductance parameters called 4 and resistance change the resistance open and right here 10. Okay, and similarly a resistor 1 right 10. For simplicity I'm taking all resistors are same 10. So this is called voltage control voltage current source connection circuit diagram connection. And to solve this one ground is also required, that is called electrical reference. Take electrical reference here, connect electrical reference to this ground. And also one solver configuration is required to run the simulation. Solver configuration is required. Okay, place here, connect to the ground terminal in this way. Okay, so this is called circuit diagram, and here voltage for example 100 volts. Okay, so this is circuit for current voltage controlled current source with the dependent parameters. First one. Okay, and then save as voltage controlled current source VCCS. Okay, right here VCCS voltage controlled current source, and same simulate, and then you will get the voltage and current. How to find the voltage and current in particular bands? Okay, connect here one voltage sensor. For example, you want to find the voltage across this resistor. Okay, for example, if you want to find the voltage across this resistor, connect one. For example, I'm here I'm finding the current flow into this resistor. How to find means take one current sensor. Right here, current sensor. Current sensor. In Simulink, that is called current measurement, but in simscape, so we have to use one current sensor. Okay, delete and connect a positive terminal to this positive terminal to this resistor. Current sensor. Okay, and another terminal to here. Okay, and next, how to display this current? Okay, this is called ammeter. Like ammeter, current sensor is just current, but how to display by using display. That is, display block is available in Simulink, not in Simscape. The display block is available in Simulink. Okay, that's why one PS Simulink converter is required. Simscapes to Simulink converter is required. Connect here and take one display. Press display and connect here. Okay, this is called voltage controlled current source circuit for measurement of current flow into this particular branch. For example, if you want to know the voltage across this branch, current is over, then next here I'm finding the what is the voltage across this resistor. So take one voltage sensor, not voltage measurement. Voltage measurement for Simulink circuits. Okay, and then it's voltage, just voltmeter. How to connect the voltmeter exactly parallel to the branch, na? Where we have to find, and that place we have to connect the voltmeter exactly parallel. So like this voltmeter is connected parallel, and similar way one PS Simulink converter is required. Okay, for Simulink converter is required. Simulink to Simscapes to Simulink, and then take one more display and place here. So this is called voltage sense. Understood? So like this voltage sensor is connected to for measurement of voltage. This is for measurement of current, and this is used to measurement of voltage, measurement of current. This is a dependent source. This present in the circuit, and then simulate, and it will take some time. It's compiling. 2% is completed, and then compiling and display this voltage and current for dependent circuits. This is called voltage controlled current source. Okay, voltage controlled current source. After simulating, the display will be display will display the results. Okay, so this is called voltage sensor. This is called voltmeter. So 102.6. This is the voltage across this resistor, and this is current flow into this resistor, the 10.5. So like this, we can measure the voltage and current in voltage controlled current source. Understood? And then next, coming to the new circuit. For example, this is voltage controlled current source. Na? Take another circuit. Voltage controlled current source. Voltage controlled voltage source. Take voltage controlled voltage source. Voltage controlled voltage source. This is the black. Voltage controlled voltage source like this. It will be looks like voltage controlled voltage source. And to understand, the already is completed, and delete this and take the circuit. So voltage controlled voltage source, it looks like in this way. Okay, and similarly take one DC current source, DC voltage source, or DC current source, whatever it may be. This is called DC voltage source. and take one resistor. Okay. Press slightly kick and controller, press controller, and it would rotate like this. And connect these all elements in this way. Connect all elements. Here, this circle is called source. For example, this source is present here. Okay. Connect this source first in this way. Plus minus polarity. Actually, this dependent sources represented by rhombus symbol. So, but yeah, to understand the purpose, so they are represented here. But theoretically, the dependent sources are represented like rhombus symbol. For example, this is called 2Vx. Okay, so this depends on voltage, but it is a voltage source. Okay, for example, it depends on this resistor. For example, this voltage controlled voltage source is depends upon voltage, na? That's why, for example, it depends on voltage drop across this resistor R1. For example, it is depends upon R resistor R1. So how to connect means positive to positive like this. Okay, positive to positive and negative to negative like this. Like parallel, exactly parallel. Okay, so in this way we have to connect. This depends upon this R resistor and change the resistance. For example, 10 ohms. Here also I'm changing the resistance to 10 ohms. And here also 10 ohms. Okay. And open this voltage controlled voltage source. And here voltage gain. For example, this is called 2Vx. Means voltage 2 is called voltage gain. Right, 2 here. And then take one ground. Electrical reference. Ground is nothing but Simulink electrical reference. Okay, electrical reference. Don't take ground. If you are taking the ground in Simulink only, it is possible to connect. In simscape, it is not possible to connect. Okay. For example, ground is called this ground. If you want to try to connect this ground in simscape, it's not take like this. So the red mark will be up here. This is not possible to connect because of these Simulink circuits. So ground is for Simulink, simscape electrical reference. Okay, and next this voltage is called 100 volts. Let us voltage is called, and also just like Simulink and power guy, here also one solver configuration is required. Solver configuration and place here. To run Simulink flux, some solver configuration is required. What is this voltage controlled voltage source? VCVS. VCVS. Then press here. Save as VC VS. Voltage controlled voltage source. Press. Save. Then here stop time is 10 seconds. Right here 1 seconds and then simulate. The result will be displayed. So without voltage sensor, current sensor, how to display the voltage and current? That's why. So connect voltage sensor and current sensor. Here, for example, voltage sensor here, current sensor here. Otherwise, current sensor here, voltage sensor. Take one first current sensor to find the source current. Connect, place here. Connect exactly in series with this meter. Okay. For example, this is called current sensor. To find the source current, remove this, delete this element. Current flow into this resistor. I want to measure current flow into the resistor. So how to means by using ammeter. Connect positive terminal and a negative terminal to here. Like this. Okay, this is called current sensor. Like this current sensor is connected. And to display the current, what is this display? To connect a display, PS simulink converter is required. PS simulink converter, and press here like this. And to want to display this current, one display block is required. Display block like this flash. This is called display. Okay, to display the current. And next, take one voltage sensor. To you want to measure the voltage across this. Okay, voltage sensor is required. Voltage sensor. To want to measure the voltage across this, take one voltage sensor. Voltage sensor. Voltage sensor like this. So connect this voltage sensor exactly parallel to this resistor. So positive here and negative connect here. So it's extend some downside. Then it is easy to connect. Negative connect it. So like this voltmeter is connected. And then take one PS simulink converter. Okay. PS simulink converter. For example, here simulink converter. And take one display. So like the simulink circuit connection is over. Okay, this is called circuit. So voltage sensor and current sensor, and to measure the current and to measure the voltage, and then simulate and current and voltage display after simulating. So this is called current flowing in the resistor connected in ammeter is connected in series 5.714. Okay, 5.714 is called current flowing in this resistor, and voltage across this resistor is called 42.86. So this is a voltage controlled voltage source. Voltage controlled voltage source. Okay, so in this way we have to simulate the dependent sources, voltage controlled voltage source. Then coming to the another circuit that is called current controlled current source. Delete this and take one new one that is called current controlled current source. Current controlled current source. This is called current controlled current source. The current controlled current source is looks like this. Okay, this one. Current controlled current source. And take one simple circuit same as before. Take one voltage DC voltage source. DC voltage source. Don't take this type of DC voltage source. DC voltage source like this. Okay, and take one resistor. And take another resistor, and here solar resistance. These are the branches in electrical network connect in this way. Okay, so this connect to this terminal like this. For example, this voltage current source is present here. The circle is nothing but circle is called, what is the circle? It's called source. Okay, and connect this terminal here, and the next terminal here, and another terminal like this. So in this way, the circuit is connected, and so where it is depending on current, this is called depending current. No? That's why current controlled current source. Is depending on current. previous one voltage depends, but here current depends. So the, for example, it's depending on current flow into this resistor. For example, current flow into this resistor R2 is called this. For example, 3ix. 3ix means ix is nothing but this is current. Current flow into the R2 is called ix. Okay, 3ix. For example, 3ix means open this current controlled current source and right here current gain is called 3. If it is 3ix current controlled current source, gain is called current gain is called 3. And then here connect in series. Delete and positive terminal connect here. Current entering in this way and leaving to the connect here like this. Okay. So like this current entering into the branch in this way. Current entering and leaving to the resistor. That is called like series connection. Okay. So this direction of current is same as this current direction. Okay. So like this we have to connect the current controlled current source. And then next change the value of resistances to 1 to 10. Here also 10. The resistance is called 10. Here also change the resistance is 10. Okay. And this voltage same as usual and take 100 for simplicity understanding purpose. And this is called current source and gain is called 3 amps. And take one electrical reference and connect electrical reference to the ground. Okay. This is called electrical reference and then take one solver configuration and place here, connect the solver configuration in this way. And next to measure the, for example, here voltage or current, for example, here current, take current sensor to find the current source current, take one current sensor and delete and connect this terminal here and the second terminal here, this is called current controlled current sensor. This is called ammeter and take one PS Simulink converter and place here and take one display and place here display connected display. So this is the current to measure the current and take one voltage sensor to measure the voltage across this branch, for example. Okay, voltage sensor, connect to positive terminal here and connect to negative terminal here. Okay, this is called voltmeter and take one PS Simulink converter, connect here PS Simulink converter to measure the voltage and take one display, place display like this. Okay, and all circuits, all elements connected. This is called current flow into this element and this is called voltage across this. And then next simulate. This is called current controlled current source. Here current is called 20 amps. That can be measured by using this current sensor. And voltage across this resistor is nothing but 300. Voltage across this resistor is nothing but 300 volts. So in this way we have to measure the voltage and current by using simscape in current controlled current source. Then coming to the current controlled voltage source. Current controlled voltage source. Right here, current controlled voltage source like this. This is called current controlled voltage source. It depends on current, but it is voltage source. This voltage source circle is called voltage source, but it is depends on voltage, current. Okay, current flow into the branch. Then how do you disconnect? Take one voltage source. Otherwise, take one current source. current to source, current source like this. This is called current source. And take one resistor, and copy resistor, and press controller. In this way, the current sensor is connected. Connect this in this way, all elements. Must connect that. Okay, and then next one electrical reference is required. Electrical reference, connect electrical reference in this. And then take one is called solver configuration. Solver configuration. Place here and connect here. And the next, what is this current? Take another current source. So DC current source. DC current source. Not like this. DC current source. Open this DC current source like this. Remove this DC current source and place here. Open DC current source. For example, 10 amps current. For example, 10 amps of current supplied by this source, DC current source. And this resistance 10, change 10, resistance like this. And this is resistance also change 10, same 10. Okay, here also same 10 ohm resistance. And current, for example, this is called depending parameter. For example, it depends upon current flow into the resistor. Okay, current flow into the resistor 1, it depends upon current flow into the resistor 1. Let us assume. Okay, so how to connect means connect in series with this resistor and remove this terminal, and current entering into the this, okay, terminal like this, current enter from here. In this way, the current entering into this current controlled current source and leaving and entering into the same resistor. The direction must be same. In this way, we have to connect. Current entering into the current control current source in this direction. Arrow is start downwards, so that's why same downwards, and leaving into the resistor same way. So in this way, we have to connect. Okay, this current control voltage source. And for example, here, what is the trans conductance? For example, 4Ix. It is represented Ix like this, 4Ix. So 4Ix means here 4. Let us assume 4Ix means here trans conductance enter like 4X. So all resistance are also changed and the control voltage also changed. Then to measure the voltage across this, same as previous, take one voltage sensor, connect parallel, exactly parallel to this one. Okay, in this way parallel, and another terminal connect here. This is called voltage sensor. And then one PS simulink converter, and connect here PS simulink converter, and take one display, connect in this way. So this is called voltage sensor. Okay, and then next, if you want to connect current sensor, also you can. So like this, it is connected. For example, I am interested to find the only voltage. So that's why I'm taking only one voltage source. Okay, and then simulate. Okay, simulate again. What is the voltage across this? Is nothing but it shows what is the is not connected properly. That's why it is shows 0. Connect proper way and simulate. So this is the voltage across this resistor is nothing but 100 volts. Okay. In this way, we have to simulate the uh, 4 different types of sources: voltage controlled voltage source, voltage controlled current source, current controlled voltage source, current controlled current source. Like this, 4 different dependent sources can be simulated by using Simulink. Okay, so this is about electrical circuit simulation with the dependent sources for measurement of voltage, current, and also power. If you want to measure the power, okay, take one power sensor and connect here. Okay, for example, if you want to, measure the power sensor. Okay, this is called power sensor. Understood? For example, if you want to measure the power across this, okay, power across this. So how to connect means for example, here you want to measure the power. So if you are connecting the power, measure the power, yes, circuit will looks zigzag. That's why. So I'm connecting the power for measurement of power here. I'm connecting the power sensor here. And here, what is this resistor on branch terminal? Here I would like to find the current flow into this resistor, and also I would like to measure the voltage, and then voltage into current is called power. That's not. So connect this terminal here. Current enter into the resistor, and another terminal current connect here. Okay, and exactly parallel to this device. Voltage across this resistor. So exactly, this is connect to voltage. These 2 terminals exactly the parallel to the resistor, and connect in series like this fashion. Okay, current entering into the power sensor in this way, like series. That is called current entering into the power sensor in this way. Current is over, and then this is called voltage, positive terminal here and the negative terminal here. So voltage parallel, current series, and then take one PS Simulink converter. PS Simulink converter. Place here PS Simulink converter, and take one display. So simulate. So 340.3 is nothing but power across this R2 resistor. Power absorbed by the R2 resistor. Understood? So in this way, we have to measure the voltage, current, and power for dependent sources. This is about for dependent sources, measurement of voltage, current.